Hello, my name is Karl Bream and I lead strategy at Nokia Enterprise. I want to begin today by saying thank you to the Center for Connected Medicine for hosting this event. And truly, thanks to you for spending your time today in this virtual space. We are all going through an unprecedented time. I'm glad that we can come together, leveraging technology to advance the education and discussion about the future of healthcare. Today, I'd like to talk to you about the disruptive potential of 5G. First, you need to forget 5G. Forget what you experience when that icon on your phone comes up and indicates you're using 5G or 5GE. That's not what we're discussing today. Today, we'll discuss the disruptive potential of 5G. And to do that, we need to take a peek into the future. So let's imagine what we call Industry 4.0 first, and then Healthcare 4.0 in full realization 10 years from today. We'll start with manufacturers who are early adopters, but listen for corollaries to health as I talk about the factory of the future. Of course, the factory of the future is a place full of technology, with thousands of sensors feeding raw data into an AI-controlled platform in real time. Autonomous mobile robots are running 24/7. Mixed reality platforms are used for worker assistance and professional training. And the production line in this factory can be reconfigured quickly because the factory no longer makes 1 million copies of one product, but it makes 1 million unique variations of a product to support personalized products and mass customization. Because the line can be reconfigured so quickly, new products can come to market in 1/10 the time. Further acceleration of time to market is achieved because there's less lost time searching for tools and components due to real-time tool tracking. Sustainability in the factory is achieved with 80% less water use and 90% less waste. An engaged, replenished, and safe worker enjoys new digital skills mastery thanks to customized upskilling programs that are available to meet their certification and safety requirements. Outside the factory is a completely autonomous, self-orchestrated, and self-optimized supply chain. It is enabled by end-to-end and real-time visibility to ensure human safety and business continuity. The December 2020 holiday peak volume in the supply chain happens every day in the future. And to process that volume of cargo, connected warehouse automation systems are required. AI and analytics engines optimize picking patterns and delivery routes to save time, energy, and emissions. Autonomous and remotely controlled vehicles, whether tool carts, delivery bots, or drones, effectively deliver the final product to its destination. The factory and supply chain of the future is only possible due to the enhanced predictability and latency of 5G and likely 6G. We are imagining 10 years in the future after all. And the benefits of this future aren't limited to back-end production and logistics. Imagine the customer experience. To do that, let's switch to the transportation industry for an example of the railway of the future that's enabled by 5G. Imagine trains that are moving at 325 miles per hour, which is over 100 miles an hour faster than today's trains that run at 225 miles an hour between Beijing and Nanjing, China. At that speed, there is only one option for high bandwidth mobile connectivity. Those trains run with limited operational interruptions due to time to event maintenance predictions and autonomous driverless control. Passengers get to their destination more quickly while sitting safely and comfortably with reliable connectivity for work and play. Actually, this example may not be 10 years in the future because earlier this year, we announced the first 5G-enabled driverless train with Deutsche Bahn in Germany. Now, let's move a little closer to our hearts and look at Healthcare 4.0 and the connected healthcare of the future. We can start with patient care. Our future begins outside the walls of the hospital, where lifeline emergency support is provided prior to a patient or a patient's arrival at the emergency center. Our patient is receiving the best care possible because the lifeline emergency vehicle and the emergency center are connected in one virtual collaboration space. Care data about the patient is being shared over the 5G network in real time with 8K high definition video. At our patient's destination, their healthcare team is preparing to deliver care based on real-time medical and observational data they have received through the virtual collaboration space. They have engaged not only with Lifeline emergency vehicles, but also with other remote specialty doctors from another facility who have joined the virtual collaboration space to provide remote care support. Once our patient arrives, their information and care is instantaneously available through the facility and the healthcare system. As our patient receives care, his EMR is updated in real time because the medical care systems, devices, and tools are no longer simply an isolated product. They are a connected and integrated element with the broader healthcare system, and data is communicated over the health system's private 5G network in real time. While connected, data privacy is enhanced by military-grade security that is offered by the 5G network. The exact usage of the medical device and tools is monitored, and the data is appended to the health record to improve billing accuracy and value-based pricing. Further, monitoring of the device or tool can be analyzed for time to event predictions, which can be used for preventive maintenance and certification reasons. You could probably spend another hour talking about improved patient care. But I want to move on to health system operations because efficiently delivered low-cost care is an imperative. Our patient was quickly cared for in part due to the virtual collaboration space. But she also received rapid care because our facility of the future monitored patient flow with high accuracy indoor positioning and continuously relieved bottlenecks in the process to improve the patient flow and the patient experience. The personnel supporting our patient were able to deliver services efficiently because they were no longer spending time looking for missing wheelchairs or misplaced infusion pumps. In fact, leveraging data and AI about our patient, the health systems predicted the wheelchair would be required, located it, and scheduled delivery through an automated workflow. This has helped relieve the challenge of available skilled resources and medical supply issues. Unfortunately, we can't stay in the future, so let us return to the present. You would probably not be tuning in today if you were not already focused on connected medicine and the technology that will enable the digital transformation journey in healthcare. But our journey is not the same journey as other industries have taken. Historically, other industries have replaced physical assets with digital copies. Think Amazon and Apple with books and music. But that's not our journey. While we have digitized medical records, our assets generally are not information-based. Our MRI and CT scanners, our infusion pumps and surgical tools, wheelchairs, and controlled substance carts cannot be replaced with digital copies. But we can create significant value and better outcomes by taking additional digital control of those physical assets. We control physical assets with digital programming through digital twins, process twins, even a hospital twin. At Nokia Bell Labs, we call this replication of the physical world Mirror X. And it takes and requires more information, more analytics, and more predictability to improve the efficiency, productivity, customer satisfaction, and safety. But to achieve that level of control, we need to elevate the level of reliability, performance, and predictability of the network across all the assets and ecosystems. But that level of network performance has not always been the focus of today's health tech or IT. For example, today's wireless connectivity doesn't speed up or improve the performance of a mobile robot. In fact, it sometimes takes two robots to do the job of one human. Today's wireless is typically designed for 99.9% reliability, or what we call 3 nines. But some mission critical healthcare applications require 6 nines, 99.9999% reliability. That's 3 orders of magnitude difference in reliability. We need to see a different kind of network than most healthcare systems have deployed today if we want to serve the critical needs of healthcare in the future. And this is where the disruptive power of 5G sits. It's why many are calling 5G the catalyst for Industry 4.0 and Healthcare 4.0 and the mission critical systems and the automations that they deploy. With apologies, we're going to get a little technical now. But it's important to move beyond the headlines of 5G to get to the physics of 5G to understand why it is so disruptive. First, let me talk about the capacity of 5G. Capacity is what we experience and know as consumers. 5G delivers 10 times, or an order of magnitude change in capacity from today's connections, and it delivers 10 gigabits per second per device. And this is important. The capacity can be dynamically allocated to uplink or downlink, and it does not degrade as quickly as other wireless services as the number of devices on the network increases. Why is this important to healthcare? First, while consumers download far more content than they upload, enterprises, including healthcare companies, are more balanced. We upload high-res digital images and we download high-res digital images. Healthcare capacity needs to be in both directions. Likewise, while as consumers we might be more accepting when our family and friends' devices degrade our wireless service, in healthcare we need predictable capacity to ensure critical tasks are completed, and that's why the capacity of 5G is so important. Now, let's talk about reliability and performance. We discussed earlier 6 nines performance requirements in critical wireless systems. That level of reliability is delivered indoors and outdoors across a much broader coverage area and with military-grade security. That means a much more consistent coverage is available as people and things move about the health campus. Finally, let's talk about latency. Latency is the time it takes for your information to travel to its destination. It's sometimes confused with capacity because capacity is measured by megabits per second or gigabits per second. This sounds like speed, but it's not. It's capacity. 5G has an order of magnitude improvement in latency over any other form of wireless communications and can reach below 10 milliseconds of latency to as little as 1 millisecond. To put that in perspective, that is as fast or faster than your vestibular ocular reflex. That's how long it takes your brain and eyes to react when you turn your head. That's pretty fast. It also happens to be the latency required for autonomous remote control vehicles and drones. Now, usually when people hear me talk about the physics of 5G, a common question comes up. How do I know if I need it? What do you see in this image? Of course, it's a surgical room, but what else do you see? You'll also see reflective metal surfaces. Non-industrial grade private wireless, like Wi-Fi, doesn't deliver predictable performance in this environment, and 5G will outperform. So whenever you see reflective surfaces, you know in that space you'll realize benefits from 5G. Let's look at another scenario. If your site looks like this, you'll benefit from the disruptive potential of 5G. What do we see? Well, here it's an MRI scanner. Electromagnetic fields impact the performance of wireless networks. But here again, non-industrial grade wireless, like Wi-Fi, doesn't stand up to electromagnetic fields, and 5G will outperform. Because health facilities have medical equipment that emits EMF, you'll benefit from 5G. Let's try one more. This one's a bit more challenging because what it depicts is massive machine connectivity. The number of connected devices is increasing dramatically everywhere, and healthcare is no exception. In fact, the number of connected devices is increasing so substantially in healthcare, the term Internet of Medical Things was coined. Why is this important? Because as the number of devices increases, the bandwidth per device decreases. But as I said, this happens differently with 5G. And so if you have a large number of connected devices, you'll need 5G. While those are simple ways to know if you can benefit from 5G, you can also look at the physics data. This image is data of the performance testing of a Wi-Fi networking. What the performance testing indicates, according to the IEEE, which is the governing body of Wi-Fi standards, is that the number of devices increases as the number of devices increases on the horizontal axis. The saturation of the channel in the network increases on the vertical axis. This is not at all surprising. What you see, though, is as the saturation happens at about 16 devices. How many devices do you have in your home today? How many devices will you have when remote patient care is more widely used? How many devices are in any particular area in your healthcare system? In cellular networks such as 5G, the equivalent number of devices before saturation happens is over 800. This is an example of why 5G in real industrial environments, serving real industrial use cases, is so disruptive. While the full realization of Healthcare 4.0 and the hospital of the future is not available right now, the path to 5G starts today, and many of your use cases can already be addressed today and start creating value for you today. Let's look at a few examples that focus on private 5G networks. Private networks provide 5G speeds, capabilities, and reliability in a simple plug-and-play offering similar to Wi-Fi. It is so easy for some of our customers that they are self-installing their 5G networks and can turn them up in 15 minutes. Our first example today is Oulu University Hospital. Oulu is a town in the north of Finland and is known by some for their vision of the hospital of the future. The hospital estimates that their staff spend 70% of working time for non-care related tasks and plan to use 5G to automate their logistics and operations. Nokia and 5 other ecosystem partners deployed our plug-and-play digital automation cloud for 5G, our high accuracy indoor positioning, and Omron's mobile robots to automate their operations. They track their medical equipment throughout their facilities. The results not only saved the time of their workers as expected, it enabled them to provide more care. But it also allowed the hospital to deliver faster and more accurate service for their patients. Another very recent and pertinent solution to many geographies is something we call the Automated Analytics for Access Control solution. As you might expect, many facilities were coming to us for advice on how they may protect people from the COVID-19 pandemic. The goal was an industrial, large-scale, rapidly deployable solution for hospitals, airports, retail outlets, and other large office buildings that help prevent the spread of the virus. The answer was an analytics solution that captured and processed a large number of thermal and visual images very rapidly. It needed to detect both the temperature of individuals and whether the individual was adhering to mask regulations. If they were hot or not in compliance, they were directed to a separate area for further inspection. The solution combines thermal cameras, centralized management and analytics, and private wireless for connectionless indoor and outdoor facilities. With the solution, employee safety was improved and elevated temperatures were detected in 2 to 3 people per day. So far, $80,000 in savings has been realized in continued production and reduced sanitation costs. 5G delivered with our digital automation cloud can provide this type of seamless connectivity for healthcare operations. 5G is also ideal for immersive and mixed reality applications. Mixed reality systems are already being used in medical training, and 5G will unleash new applications in the future, including rehabilitation, pain management, and mental health. In addition, haptic or touch-based interfaces for medical simulation and training are used for minimally invasive procedures such as laparoscopy and interventional radiology. These systems can be enabled with low latency 5G, which will eliminate the lag, the stutters, and the stalls that prevent wide deployment of the technology today. Interestingly, studies have indicated that medical students learn more when using mixed reality systems, and when in surgical training, they have been shown to decrease injury, increase the speed of operations, and improve overall outcomes. At Nokia, we are serving healthcare's next generation requirements. And so we're asked often about what our key takeaways are based on our experiences. I think the key takeaway is that technology alone will not make you a leader in the future of healthcare. It takes deep domain knowledge in care delivery and the operations of a health system. It takes technologies like 5G and hyperscale networking. It also takes the know-how to pull it all together and integrate it into existing systems and workflows. This is the last area I want to mention that permeates everything, and that is the ecosystem that you engage with to deliver these advances. We are continually broadening our ecosystem. We work with leaders in the medical device and diagnostic industry. We partner with cloud providers, system integrators, and consultants like Microsoft and EY. We are very frequently partnered with service providers such as AT&T and Verizon, including some very significant announcements in October of this year. We believe a set of leading partners like these can help deliver the health system of the future that I spoke about at the beginning. In summary, 5G will disrupt the status quo and deliver value to Healthcare 4.0. Now is the pivotal point. Ecosystems are forming and in place. COVID has accelerated the acceptance of new ways of delivering care. The US health industry can lead in the use of private 5G networks to improve patient care and outcomes and to help health systems become more productive and efficient. Thank you.